Bismillahirrahmanirrahim. Assalamu alaikum students. Hope you all are fine and feeling great. Today it's our lecture number 7 from chapter 5, the physical states of matter. As in the previous lecture we discussed about the liquid state. So today we are going to know what is the boiling point and what is the effect of the external pressure on boiling point. So first of all, what is boiling point? The temperature at which vapor pressure of a liquid becomes equal to the external or atmospheric pressure is called boiling point. It means that if we heat some liquid in an open container, the liquid starts converting into its vapors, and we know that the vapors exerts a pressure that is called the vapor pressure. And when the vapor pressure of the liquid becomes equal to the external or atmospheric pressure that is exerted by the atmosphere, that is called the boiling point of that liquid. Means at that temperature the liquid starts boiling. Explanation: in an open container, atmosphere exerts pressure on the liquid surface. When it is heated, average kinetic energy of the molecules increases, which means the temperature of the liquid increases. Heating allows larger number of molecules at the liquid surface to overcome the attractive forces responsible for keeping them in the liquid, which increases the vapor pressure of the liquid. It means that if we take some liquid in an open container and we heat that liquid, so after heating, the average kinetic energy of that liquid increases, due to which the temperature of the liquid increases, and with the increase of the temperature more vapors will form and increase the vapor pressure of that liquid. Means vapor pressure of the liquid keeps increasing with increasing temperature. With the increase of the temperature, the vapor pressure also increases, and when the vapor pressure increased, they exert more pressure on the liquid. At a certain temperature, the vapor pressure of the liquid becomes equal to the atmospheric pressure or external pressure. At this stage, liquid starts boiling. Bubbles of the vapors form throughout the liquid, rise to the surface and escape into the air. A time will come when the vapor pressure of that liquid becomes equal to the atmospheric pressure or external pressure, means the pressure that is exerted by the atmosphere, that is called the atmospheric pressure. At this stage, the liquid starts boiling and bubbles will form and rise to the surface, and we can say it is the boiling point of that liquid. And different liquid have different boiling point. Here you can see the difference between evaporation and boiling. Evaporation, as we discussed in the previous lecture, that it can occur at any temperature because the vapor pressure is less than the atmospheric pressure and bubbles cannot form in the evaporation. While in boiling point, the vapor pressure is equal to the atmospheric pressure. Bubbles can form and rise to the surface, and different liquid has different boiling point. So now if we draw a graph between the pressure and the temperature, here we can see that different liquid has different boiling point. So as ethyl ether, its boiling point is about 35 to 38 degree Celsius. As ethyl ether boils at 35 degrees Celsius, because at 35 or 38 degrees Celsius its vapor pressure becomes equal to the external pressure. The dotted line above shows that it is the external pressure, that is about 101.325 kilopascal, or it is about 760 millimeter of mercury or 1 atm. Similarly, the second liquid, that is ethyl alcohol, it boils at about 78 to 79 degrees Celsius, because at this temperature its vapor pressure becomes equal to the atmospheric pressure. And similarly, the boiling point of water is 100 degrees Celsius, because at 100 degrees Celsius its vapor pressure becomes equal to the external pressure or atmospheric pressure, and the boiling point of ethylene glycol is 120 degree Celsius. So now what is the effect of the external pressure on boiling point? Means whether the external pressure affects the boiling point, will it increase the boiling point or decrease the boiling point? So boiling point depends upon external pressure. Means the boiling point of a liquid decreases with the decrease in external pressure. Liquid boils when their vapor pressure is equal to the pressure exerted on the liquid by its surroundings. The normal boiling point of water is 100 degrees Celsius. Means at sea level where the atmospheric pressure is 101.325 kilopascal or 1 atm or 760 millimeter of mercury. So water boils at 100 degrees Celsius. Means the normal boiling point of water is 100 degrees Celsius but at sea level. Similarly, in the mountain, the atmospheric pressure is lesser than the atmospheric pressure at sea level, that is 760 millimeter of mercury or 101.325 kilopascal or 1 atm. Therefore, water boils there below 100 degree Celsius. Means if we move at a height, means the as we know that at height the external pressure decreases, so the boiling point of water also decreases and the boiling point is not 100 degree Celsius. So now let's see what happened there, that when the pressure of atmosphere is 1 atm or 101.325 kilopascal, means at sea level, so water boils at 100 degrees Celsius. But at Mount Everest, which is about at a height of 8,850 meter above sea level, so atmospheric pressure is only 34 kilopascal. When the atmospheric pressure is decreased to 34 kilopascal, so water does not boil there at 100 degrees Celsius, and the boiling point of water at Mount Everest is 70 degrees Celsius. And similarly, while in pressure cooker at 2 atm, water does not boil until the temperature reaches 120 degrees Celsius. And the people who live at height, they use the pressure cooker. What is the reason? That because the pressure cooker is equipped with a valve that controls the pressure inside the pot. This valve generally exerts a pressure of 2 atm. In pressure cooker, an artificial pressure is formed that is about 2 atm. Therefore, the valve does not allow water to escape until the pressure inside the pot reaches 2 atm. Because the vapor pressure of water becomes 2 atm when the temperature reaches 120. So water boils at 120 in a pressure cooker. So that's why the boiling point of water in pressure cooker increases to 120 degrees Celsius, because the atmospheric pressure is 2 atm in a pressure cooker. Here we can see that at different height liquid have different boiling point. Like first of all, at sea level the water boils at about 100 degrees Celsius, because it is the atmospheric pressure is 101.325 kilopascal or 760 millimeter of mercury. Similarly, if we move at a height of 1800 meter from sea level, so the boiling point of water decreases to 93 degrees Celsius. If we move further at a height of 3000 meter from the sea level, the boiling point further decreases to 90 degrees Celsius, and at a height of 6000 meter above the sea level, the boiling point further decreased to 79 degrees Celsius. This shows that as we move at a height, the external pressure decreases, and due to which the boiling point of the water also decreases. So now students, it's your homework. You have to solve self-assessment exercise 5.5, and from review exercise question number 2 you have to solve part 3 and part 5. Thank you.